In this video, we're going to do an example where we're computing the cross product for two vectors. All right, so consider the following vectors, A and B, which are already drawn for us. All right, and they're drawn in the XY plane. And we're given the magnitude of each of these vectors and the angle between them, which is kind of nice. We're already given the angle between them, which is what we need for computing the cross product. So remember, there are two ways to compute the cross product, and one of them will be way easier than the other one in this particular case. So what I'd like you to do is to pause the video here and try to compute it on your own before we do it together. All right, so hopefully you realized that the formula for when you're given direction and magnitude is the easier one to use. So remember, there are sort of two steps in doing the cross product using this formula. The first is to find the magnitude of the result, and the second is to find the direction of the result. So the magnitude, and I can really write the magnitude of A cross B, where what I mean by this is that's the magnitude of the vector that is a result of computing the cross product A cross B. This is given by the magnitude of A times the magnitude of B times now sine of 30 degrees, where remember we use the sine for computing the cross product and the cosine for computing the dot product. So this is equal to 2 times 2.5 times, sine of 30 degrees, which again is the angle between the two vectors, which we were given happily. If you plug this into your calculator, you should have gotten 4.3. If you did not get 4.3, it might be because your calculator is in radians instead of degrees, so double check that. All right, so we aren't done because the cross product gives you a vector, and right now we've only found the magnitude of that vector. Now we need the direction. So we want to find direction using the right-hand rule, which I'll abbreviate as RHR, the right-hand rule. So again, what do? We take our right hand, not our left hand, our right hand. We put our fingers up against our paper, and we start by pointing our fingers along the direction of the first vector. What is the first vector? The first vector is A, right? I'm computing A cross B, not B cross A. For A cross B, A comes first. So I put them along A, and now I want to curl my fingers towards B. And you want to curl them sort of the shorter distance towards B. So if I curl them this way, I have to go all the way around to get back to B. So instead I have to flip my hand over. So it's pointing, my fingers are still pointing along A, and then curl them towards B. And now you can see my thumb ends up pointing sort of directly at you. And so what that means, if you were doing this holding it up to your paper, as I recommend you do, you should find that your thumb ends up naturally pointing into the plane of your paper. So your thumb should end up pointing towards the paper. But if you put your fingers along A, if you draw it on your paper, which you really should do this on your own, don't just watch me and think you'll be able to figure out the right-hand rule. You really have to do this on your own. Draw these vectors A and B, put your fingers along A, twist your wrist such that you can naturally curl your fingers the shorter distance to B, and your thumb should end up pointing into the page. And so A cross B points into the page, which we can write as this way. And remember, the symbol should look like an arrow flying away from you. So it's into the page instead of out of the page. And if we wanted to really summarize this information in a nice presentable form, we could write A cross B equals 4.3 into the page. And that would be a really nice way of summarizing all of this information. Or if you like, that also happens to be the negative z direction. So this is equal to negative 4.3 z hat with the coordinates as I've drawn them. All right, so that's how you compute the cross product given the magnitudes of your vectors and the angle between them.